My name is Ullas Karanth. I am a tiger biologist with the Wildlife Conservation Society. I have been fascinated with these big cats ever since I was a little boy. Although I study them as a scientist, my connection with tigers is also an emotional one. I think they are the most extraordinary animals on the planet. Sadly, this great predator has been wiped out from 93% of its former range in Asia. Wherever it survives, it is threatened by three serious problems: hunting of its prey by local people, poaching for its skin and bones by organized criminals, and habitat destruction. Yet, in some of the reserves where I work, in southern India, tiger numbers have actually doubled during the last few decades. I am optimistic that they have a secure future here if we continue to do the right things. I decided to study tigers because understanding their ecology is critical to saving them. How much space do they need? What are their food requirements? When do they breed? Over the years, even as the questions have kept growing, so has my team, which now includes the finest tiger researchers and conservationists in the world. Together, we have created the longest running tiger program anywhere, combining innovative use of technology with boots on the ground fieldwork. This is the story of our journey into the tiger's world. When I first visited these forests as a teenager in 1967, hunting was so rampant that you were lucky to see a couple of deer in a whole day. Today, transformed by effective conservation, this landscape holds the largest wild tiger population in the world. You can also see more large mammals here than almost anywhere else in Asia. More than 3,000 Asian elephants roam these jungles. They share this habitat with herds of gaur, the largest wild cattle in the world. A bull can stand 6 feet at the shoulder and weigh about a ton, and yet it's not safe from a hungry tiger. We also have sambar, favorite tiger food, and other prey like cheetal and wild pig. Thanks to this variety and abundance of prey, predators thrive in these forests. These are Asian wild dogs. They can strip a deer within minutes. And then there are the big cats. Leopards are powerful predators, but here they are always fearful of their much larger cousins. I was inspired to study tigers after I read an article by the great biologist George Schaller, who studied them in central India in the 1960s. Many years later, thanks to George, I joined WCS and began my own tiger research in the Nagarhole forest. In 1990, I started the first ever radio telemetry study of tigers in India. My guide was the eminent carnivore biologist Mel Sundquist from the University of Florida. It was an exciting time. This is all the radio telemetry gear that I used when I tracked tigers. It involves catching the tiger using a dart gun, then putting a collar on it. So it's pretty complicated. For example, this is a dart gun. I would sit on a tree with the gun ready and a big tiger will walk right under me. It's very exciting. You have to hold your nerves and you've got to be very careful to place the dart where there's a lot of muscle on the body. And the tiger doesn't even know it's been hit. It thinks thorn has pricked it. It just grunts and moves on. So So you need the right amount of drug, so the animal is down and calm, and that's when you put the collar on. This is a radio collar. It's a pretty light thing for a big animal like a tiger. It sits around the neck of the animal, and the animal gets used to it immediately. Doesn't bother the animal one bit. And for the next 2 or 3 years, you can track the tiger's movements because you have this technology. It's very exciting, and it told me lots of interesting things about tigers. Tigers are really secretive, and you don't see them very often. To understand their ecology, you have to be like a detective. Analyze their droppings and study their kills to see what they are eating and how much. It's not a job for the squeamish.
Wear on the teeth gives a good idea.
The years of research taught me a lot about the way of the tiger. But there was still one major mystery. I had no idea how many tigers were there in the forest. Without this knowledge, it was impossible to know if the tiger population was going up or going down, and whether conservation efforts were working at all. But how do you count a ghost of the darkness? For decades, the Indian government had used the unreliable pug mark census method, which involved tracing footprints from trails to identify individual tigers. However, tracks vary greatly on different substrates, so the same tigers were often counted repeatedly, painting a rosy picture of conservation success while tiger numbers plummeted. A more reliable counting method was desperately needed, and it had to be foolproof. The convenient thing about tigers is that each animal has its own unique stripe pattern. So, by comparing photos, one can reliably identify individuals. But given their secretive nature and the dense cover they live in, getting clear photographs is often impossible. It occurred to me that the best solution might be to set up dozens of automatic cameras in the forest and let the tigers take their own pictures. This is an automated camera trap used for photographing tigers as they walk through the forest. It consists of a camera and a tripping device. When the tiger passes in front of the camera, the tiger takes its own picture. That's the beauty of the method. And you get these nice close-up shots of the tiger, and from their body stripe patterns, we are able to identify individuals. It's a technique for counting tigers that I have developed over the years, which has worked really well. And we are now able to understand not just how many tigers are in a forest, we can estimate their population densities, how these numbers change over time, and how many of them survive. These are all difficult things to understand. What proportion survive from year to year, what proportion of new animals are entering the population. These were almost impossible to estimate earlier, and now we have a technique that works. Thanks to extensive camera trapping, we are also getting incredible insights about how tigers disperse across large landscapes. For instance, this young male, which was camera trapped in the Bhadra Tiger Reserve, subsequently disappeared, only to appear in our cameras 2 years later in the Dandeli Reserve 200 kilometers away. Another tiger, code numbered BPT241, moved 280 kilometers from where it was born. Camera trapping is also proving effective as a forensic tool. When local police seized a tiger skin, our photo database traced its origin to the Bandipur Tiger Reserve, helping to prosecute the poachers. In the early years, we had to compare hundreds of camera trap photos manually to identify individuals. Today, we use specially developed pattern matching software which speeds up the work. We have here Extract Compare, a special software designed for pattern matching. As you start camera trapping tigers over many decades, you accumulate thousands of pictures, and each one has to be matched with the other to identify individuals. So it becomes very time consuming and very laborious. So this software is very smart. We developed it with the mathematician Lex Hebe in UK, and what it does is summarize the information in the stripe patterns of a tiger, present it in a concise form, put it into a large database, and very quickly match the patterns and give you the top 5 rankings saying these are the 5 most likely individuals that are matched. And then you eyeball it. You use all your skills to say, okay, this is the top mark. It's facilitated camera trapping analysis hugely. But counting tigers is just one piece of the puzzle. Our research showed that there can only be one tiger for every 500 prey animals. It is therefore necessary to count prey numbers accurately to know how many tigers can live in a forest. Since it is impossible to count every prey animal in a jungle, I had to refine line transect sampling methods that could generate reliable estimates. However, the real challenge was how to sample thousands of square kilometers of forests every year. So, I began training local naturalists who volunteered to collect field data. They were taught the basic principles of sampling and the use of instruments such as a rangefinder that are necessary for the task. Every year, dozens of volunteers and WCS scientists walk transect lines spread all over the Malenad-Mysore landscape to get a handle on prey numbers. On the left is Dr. Samba Kumar, who has helped me train hundreds of volunteers. Samba himself began as a transect volunteer in 1989. He later joined WCS full-time and is one of India's best field biologists. Other early transect volunteers, like Girish, a local coffee farmer, have become respected conservation leaders. Girish works closely with WCS to safeguard the splendid Bhadra Tiger Reserve, which is literally his backyard. Until 2002, over 3,000 people farmed inside the reserve. There was rampant hunting, cattle grazing, and serious human-wildlife conflict. People were losing livestock to predators and retaliating by poisoning them. It was a no-win situation, and something had to be done. With support from WCS, Girish worked tirelessly with the local communities, giving them the confidence to accept a government-sponsored relocation scheme. Today, in a fertile agricultural area outside the reserve, the same people farm peacefully, without fear of wild animals, and are reaping rich harvests. Just as important, their children now go to school in safety and can look forward to a bright future. As for the Bhadra Reserve, our research shows that prey animal numbers have already doubled since people moved out, and tiger numbers are beginning to rebound. So what started out as a small tiger research program in the 1980s has blossomed into a many-sided conservation program. A program that has helped create a new generation of researchers who not only excel at hard fieldwork but also at cutting-edge quantitative analysis. In this, we are fortunate to be guided by one of the world's leading statistical ecologists, Jim Nichols of the US Geological Survey. Along the way, we have generated a vast body of knowledge that is helping to save the big cat throughout its range. The WCS program has also helped nurture dedicated local guardians for wild tigers across the landscape. A band of conservationists who feel a deep sense of ownership over these forests and are willing to defend the tiger. The Malenad-Mysore landscape, with about 25,000 square kilometers of potential habitat, is the most promising refuge for the long-term survival of wild tigers. When I was growing up here, tigers were almost extinct. Today, our research and monitoring conclusively show that their population is flourishing in some reserves. I have every reason to believe that their numbers can increase even further if the government and conservationists focus on doing the right things. Helping to save tigers has been my life's work and purpose. My team and I are determined that, at least in this corner of India, wild tigers will forever roam free.